Hello everyone, and welcome to the second Arduino tutorial about how to make an LED fade up and down. For this tutorial we're going to use pulse width modulation. What is pulse width modulation? PWM? Well, digital means that an LED is either on or off, ones and zeros. And that can be pretty frustrating when you're trying to control the speed of a motor, or in this case make an LED fade on and off. And so pulse width modulation is a trick where you control not the ones and zeros, not the on and off, because it's still digital, but how long the pulse is for. So you can have some short pulses or long pulses, and that can trick it into thinking that it's actually going through all of the values. So in order to do this, the code's already written for us. It's another example. We're going to go into the Arduino and go File, Examples, Basic, and Fade. So I'll pause while you do that. And I'll get my code ready here. Okay. We're going to ignore these for a moment. Looking at the setup, this time we're using pin 9 as an output, as opposed to last time when we used pin 13. That's because it's a pulse width modulation. Pin 9 is pulse width modulation pin. And in the loop here, which is once again the part of the Arduino code that's going to repeat over and over and over again, we are going to use the analog write this time in order to send not just a high or a low, but send to pin 9 whatever the value of brightness is. Now in the beginning of the code we initialize brightness to be 0. The int means integer, so it's a whole number, and then we set it at 0. And then at the beginning of the code the LED is off. Then throughout the code, as the code loops, it adds to brightness, it sets a new value for brightness, and it adds the fade amount. Now at the beginning here we made the fade amount 5, and that controls how quickly the LED fades in and out. And so each time through the loop it adds, in this case, 5. So it starts at 0, then it adds 5, then it adds 10, 20, 15, 20, and so on. Next thing it encounters in the loop is an if statement. Looks complicated, but it's actually pretty simple. It makes sense that if the brightness is 0 at the very bottom, the LED is off, which is what this means, or the brightness is at 255, which is the max, 255 just because of memory issues. So if the brightness value is that you're at 0 or the maximum 255, then it says reverse the fade amount, meaning turn 5 into -5. Or 10 and -10, whatever the situation. So it goes 0, 5, 10, 15, 20, and so on, and then it gets to 255. That triggers the if statement, and that turns that 5 into -5. So now it starts going 255, 250, 245, 240, and so on back down to 0, and then again it will trigger the if statement again, which will turn that -5 into 5. So it's basically the vector. It tells the LED to increase upwards, meaning on, or downwards, meaning off, but by an incremental amount. That's that pulse width modulation. So at the end is the delay for 30 seconds, and that is once again just even though it's a really small delay, it's to make it so that our eyes can see it. Otherwise we would just see this constant on, because the pulse width modulation is going so fast. So we delay it by less just because we're doing a pulse so quickly, but we still need to delay it. So in the next video I'll show you how to use a breadboard to wire all this up, because it's a little bit different than the Blink tutorial, and we'll upload the code and you can see it actually working. Cool. So thanks for watching, and I'll see you in the next tutorial.